Alright, so I think this is recording. Let's take a look at this rational function. Find the intercepts, the x and y intercept, find the end behavior, find any vertical asymptotes if they exist, find any holes if they exist. To start out, if we go in and find the intercepts, if we want to find the y-intercept, we let x equal 0. So that's replacing, by principal substitution, replacing x with 0. In the numerator we get negative 20 because these first terms are just 0. Then in the denominator, the whole thing, we've got x everywhere, so that's 0, so that's undefined. So this has no y-intercept. This graph does not cross the y-axis. So if we come in to find any x-intercepts, there may be more than one. We let y equal 0. That's the output of the function. We know that a fraction will reduce to 0 only if the numerator is 0. But we've got to be careful before we just jump in with the numerator. With variables in the denominator, we might have things that cancel that might have a hole, and you can't be a hole in the graph and an x-intercept at the same time. All of these numbers in the numerator are even, so let's factor out a 2. In the denominator, they all have a common factor of x. Let's shrink this up and give me a little bit of room. So the only way to get 2x squared is 2x times x. But with negative 10, we might have 1 and 10 and 2 and 5, and one of the factors has to be positive, one has to be negative. The middle term here is positive, so oh, if I make this a minus 4, and 5 minus 4 is 1. So there we go. Sorry about that. It's starting to get late. 2x times x gives me 2x squared. Factors of 6 are 2 and 3 and 1 and 6. Everything here is positive. So if I put plus 2 here, that'll give me a 4x. And 4 plus 3 is 7. So that's how that factors. So I don't see any common factors that cancel. So I can focus my attention on the numerator. If this fraction reduces to 0, it's because of that numerator. So 2 times 2x plus 5 and x minus 2. Multiplying by 2 is never going to produce 0. But if this x were negative 5 halves, the 2's would cancel, and negative 5 plus 5 is 0. And 2 minus 2 gives me 0. So I claim that this graph will intersect the x-axis twice, once at negative 5 halves, and then again at positive 2. I claim it will never cross the y-intercept, never intersect. I don't know if it's going to be a cross or a touch and turn or things like that, like we did with the polynomials. All right, so let's determine the end behavior. Let's compare the degree of the numerator against the degree of the denominator. This numerator is in standard form. It's a quadratic equation. Its degree is 2. This denominator is in standard form also, and its degree, this polynomial, is of third degree. So it's bottom heavy. When it's bottom heavy, that end behavior is a horizontal asymptote. And when it's bottom heavy, it's always the x-axis, which is the line y equals 0. Some people may prefer to say, well, as x is approaching negative infinity, we know that y is getting closer and closer to 0. as x is going far to the right, the y values are approaching 0. So either one of these is an acceptable answer for the end behavior for this rational function. So now let's find what the vertical asymptotes. So let's factor this again, I guess. Should have done this on different slides and saved my work, huh? Ah. So this numerator doesn't factor. Did I factor that earlier? 2 times 2 is 4. Look at that. I have 2 times 1. I'm an idiot. Sorry about that. Let's try that again. Alright. 2, 2x squared plus x minus 10. There we go. So 2x, x, the negative 10, but here, so I need a positive 5 and a minus 4. There we go. And this guy, now if I factor an x, that'll be x squared. Boy. That'll be x squared. 2x squared, 7x plus 6, yeah. This factors to 2x times x, get me 2x squared. The 6 is either 2 and 3 and 6 and 1, and we said that 7 is 4 plus 3, so that's 4 and that's 3. Alright, so if I'm trying to find vertical asymptotes, I don't see any factors that cancel, so I'm going to have 3 vertical asymptotes. I've got the lines x equals 0 from this factor, x equals 2 steps, subtract 3, divide by 2, subtract 2, 1 step. 3 vertical asymptotes. Now, it doesn't have any holes. There were no common factors that canceled. So we have no holes in the graph. Hope that helps.